and it was all, yes. So now it looks good. This all small bit is okay. We need everything. Okay, now we have geometry for the flow simulation. But what's happened? You came now. For what? Yes. Okay. We are doing flow simulation. We are starting to do. Okay, first thing, it's only three important things. First thing, we need negative. Yes, we need flow geometry for the flow simulation. Second thing, this geometry is also bad. What we need? We need we need to understand one other thing. Did you do geometry? Try to do it? What's happened? Do you want to do simulation? Yeah. Okay. Did you do?
You go splitting the things.
Hey, open lectures, we will do it. We create new volumes, and then we flow simulation. We finish mechanical simulation, we are starting to add geometry. To escape, if something here, it doesn't that was ANSYS, you can find this interesting article, yes. That what we have now is bad for simulation. So why it's bad? We have wrong solution if we do the simulation. Or okay, finish your geometry. First important thing, we need negative. Second important thing, this to get good results, correct results, is this thing. Yes. What it means, for example, our geometry, if you use our geometry for simulation now, then we will get wrong results. Why? We have this situation now. So, yes, this situation means our outlet inlet is too short. In reality, it's like this one. I have this in reality. Here is atmosphere, it's go out. Yes, in reality, I have this geometry, but this is bad for simulation. We have wrong results with this geometry. The problem is this problem, yes? Normally, I have turbulence, so, and then I have here outlet with turbulence, yes? So, what means my boundary condition outlet, for example? It means everything go out, yes? If I have here turbulence, then the program will say, no, here is out, so out. Yes, and now flow go back to my simulation, yes? Then the best solution to do my outlet long, yes, that I don't have turbulence more, and then it's really outlet, and then I have real result, like in reality, yes? So, for example, if I have here turbulence, and my outlet not enough long, then program tell me here is outlet. Yes. So program makes result wrong in this place. So, and then if I see in the results, okay, I need maybe a little bit longer outlet, then it's correct. So this is ideal location, ideal boundary condition, and everything what you need to know. It's better to do outlet inlet long. Yes, long. So for example, if I have here outlet and my real flow looks like this one, then program say me here is outlet. No. Yes, but in reality it looks like so one, and then maybe here is we will see in the results how it looks. So here is no problem. So my outlet inlet have to be longer, and this is the second thing. For example, 20 millimeters. We will see in results is it enough or not, but normally it's enough. If it's optical, if you see optical that is long, then it's yes, depends on other parts of geometry. Then it's long. So I use pull function 20 millimeters It looks long, yes. It depends on other geometry. It looks okay, yes. It looks like same proportional, then it's enough normally. And here inlet also 20 millimeters long. So this is the second main thing. My inlet outlet have to be long. So to get correct results. Okay. And we did our geometry for simulation. It was all. And second, number 3 is very, very important thing is meshing. We need special kind of meshing for flow simulation. Now geometry is finished, we are opening our mesh tool, same tool like mechanical, everything is same, one-to-one, sweep, everything is same. So same strategy, we need to, maybe more important by flow simulation to create hexa mesh. But we have so many gaps, so small gaps, we need to calculate them. Only with hexa mesh we can do it in real time, in normal, realistic time. So it's very important to do hexa mesh, but other thing is much more important is hexa mesh. Okay, please open geometry. And then we have our geometry for the meshing, same tool, absolutely, nothing different like in mechanical. Yes, our geometry for flow. Only we know that it's geometry for flow. We have same story, everything same. Only here, by four properties, yes, the program makes some properties. We can choose CFD. It was automatical choose CFX. So CFD, CFX, and then we have same story like growth rate and so on. Okay. Okay, it's our geometry. You can create standard meshing, generate mesh, and you will see how it looks. Looks not so good. So, but it's not a problem. The problem is very, very important. Very important. That the decided absolute result, wrong or not wrong. Okay. Create mesh, open mesh. Yes. Okay, we are waiting for the guys. So the main thing. So yes, flow geometry, close flow geometry, open mechanical. But it doesn't work. Look, you don't have here geometry has to be green first. It's not green. Something not correct in geometry.
Yeah, my geometry disappeared.
Yes. Okay. Then you can import again, create again.
I saved the change and it disappeared.
I don't know. Then
Maybe I didn't.
spread to
I
create.
did like ISO-Z and play.
I can quickly import it. Yes, again file, import it again. Yeah. Maybe you say, oh, okay, yes, you say this, very good. Then you can close, and open again, and create meshing, standard meshing. So the main problem by flow simulation. Hey, you can you help? Can you help maybe? It will be better.
I don't know you have a file.
So the most thing by flow simulation, you can think about it. Okay. Oh, what do you do? I think you did flow. You did flow geometry. Why you are here?
Just click at the things into
Idea we need to create geometry design. How we
Like, say, pay 30
You
euros.
see, I think the food, yeah, there is your own expenses.
Yeah, but in hostel we take with breakfast. So we take breakfast, no lunch.
Rule. So this is really important. Near the wall, I need fine meshing, and in the middle, I need minimum 2 elements. So it means here is really bad, 2 elements. I need fine meshing near the wall, 5 elements minimum, and 2 elements between walls. So, and special function we have in ANSYS, how we can do this mesh near the wall fine. So this is very important to create fine meshing near the wall. So it's called inflation function. Inflation. You can find it by mesh insert. It's special here inflation. So inflation created this fine meshing near the wall. So inflation. So then program told us where is the wall, where is my body, yes? So it means I have my flow inside object. And I need fine meshing in this connection between flow and object. Yes, this wall. So I say, okay, this body needs this special meshing inflation, and then I need to say which faces. Yes, and I need to choose all faces. Okay, inlet, it's not important. Yes, only wall. Yes, I have to think about where I have wall. Yes, I have wall always. Yes, all faces has a wall. Okay, I can do it in other way. I can choose here, for example, or other way. I can push first right mouse button, then left for a mouse button. Right and then left. So, and then I can choose like this one, all faces. So if I push again right, left, then I can choose separate faces. Right mouse button, left mouse button, then I can choose always everything and say apply by inflation. So then I choose everything. Then I can push again right, left, choose my boundary with faces, and then with strong function, yes, with contour, I can switch off symmetry faces, it's not a wall, and inlet and outlet is not a wall. Then I can say apply, and this is everything is wall, band, yes. This is the wall. It means everything near the wall have to be fine, we want to say.
Which one do you delete?
Symmetry, it's not a wall. Both faces symmetry, and inlet outlet is also not a wall.
How you have like 39 faces?
So I pushed right mouse button, then left mouse button, and then I can choose everything. And then I can say boundary apply. You see this pictogram. Look, if I push right, left, then you see I can choose, yes, this pictogram. I can choose only faces. If I push again right, left, then I can choose everything, yes, so everything. All faces. Then again right, left, right, hold, and then left. So if you push right and then hold, right and then left. So okay, this is like trick to choose it, not manual. So of course we can choose manual. So, and if we did it, it's interesting. We have different methods to do meshing. Look what's happened. Program told us, program makes 5 elements here with 20% growing. It means small elements and bigger. So, and here this transition ratio is only, we have many possibilities. So, look, we can say, for example, total thickness. It means how big is this geometry. What is the best solution? We don't need how big. We don't know. Well, first layer, yes, we can say first element 0, 0, 0, 0, 1, and then grow up 20%. It's also a bad solution. The best solution is normally this first aspect ratio is only like automatical something, but the best way is this smooth transition 0.07 something with coefficient. Look, for example, default, I create meshing now. Default is not so good. Two big elements, it have to be really small elements. Near the wall, if I choose default, we will see this interesting meshing. Yes, but it's too big, yes. It have to be really small. So small geometry, and normally I say here 0.2 by inflation. So this default transition ratio like coefficient. The more coefficient, the bigger this inflation meshing. Normally 0.2 looks good, and we say generate mesh again, and 0.2 we see looks good. But main criterion have to be phi near the wall and two elements between. So look, so it looks, now we see this inflation meshing, yes? We see 5 layers, yes? So, and we see, okay, it looks not so fine, yes, it's too big, elements are too big, looks not so beautiful, but for example, here is bad, yes? Look, here we have to see 5 elements, 2 between, but here is complete wrong. Yes.
I'm gonna write out like 41 please instead of
40. In that outlet maybe. If you know, other. Okay, try to do. Maybe you deleted more or less faces. It's okay. Try to create mesh. So you see, this is not so good mesh, and we need, of course, now to do something to do this meshing finer. What it was in lectures, it was really fine, yes. Yeah, okay. What I use always, yes, is this, how we can create this more elements between inflation. You can create with this non-cells across gap. Program try to create more elements between in the gaps. For example, 4. And this I did here. Yes, I choose now. I choose this in standard properties is proximity. Yes, it's everything what really interesting. Proximity, yes, and I told this num cells across gap 4. Or you can say element size, for example. Target is we have to do something to have inflation in the wall and 2 elements between inflation. So we have to create some, to do something, to make finer or like this one. Okay, now it's need a lot of time. Maybe now our meshing looks better. Okay, now I create this proximity for elements. Okay, it looks too fine, maybe, yes. It looks too fine, but it looks good here, yes. We see we have this inflation, 5 elements near the wall, really small, to calculate this flow gradients. And here we have also, yes, really fine. Okay, maybe we have too fine a meshing. Maybe it was not so good solution, 200,000. Then I can maybe make it again, grab 0, and maybe we can work with the element size better. We can choose our geometry and say, for example, size in 2 millimeters soft, and we can decrease them that we see good mesh. Okay, 2 elements is very best, maybe 0.5. And we can go down before we see good meshing. Good meshing means 5 elements inflation and 2 elements between. This is good. This is enough. And then we have to reduce our meshing. How do you calculate? So look, now it's bad. Yes, also bad. Look, now we have fine meshing, but in the wrong places. And this is the question: what we have to do? Maybe it was not so bad solution with 4 element across gap. It was fine, but it was good with, from inflation side. Yes? So then we try to do it like in lectures again. Okay, 200,000 elements, but okay. What can I do? Of course, we can say, for example, separately here was too much elements, we can refine here, not so fine. Okay, we have to do something, but the main target to get good results, to have 5 element inflations, 2 element between. So now it's very good.
How do you calculate 5 from there?
You see 5. You define, if you see something between, then it's 5. So here we define 5 is standard option, 5 default, and you see it optical out 5, so it's 5. But you see it, if you define it and you see between, then it's 5 here. So between we have to see 2 elements, and we have to check small gaps. Here, for example, important, yes. Here also really good, more than enough, yes. For example, here is too fine, yes, but we can say, for example, here maybe sizing 1 millimeter, that is not so fine, and then we can save some time. So, but this is the 3 main points for today, and of course, same strategy, yes. It's better to create, in your practical work, it will be good if you do also hexamesh for this task, yes. It's better to go with the same strategy, yes. I slide, for example, this my important place with maximum velocity. I slice it, I make inflation, yes. For example, here I have 2 fine meshing, do you see? But it's not logical yet, this place. I have here, I don't know, 30,000 elements, but I can slice it and make sweep with 1,000 elements or 500 elements, yes? So do you understand the same strategy? I can slice here, for example, then the other part I can use sweep method. So for example here, yes? If I slice now like this one, then I can use sweep method again. I can save a lot of 100,000 elements. So I can save with hexamesh. So, okay. Now we have this mesh, and in 2 weeks we will do the simulation. In your practical work and in your examination, you also the question, for example, question from an example from examination. You see this picture like this one, and the question is, what do you have to do to create hexamesh? Yes, what do you have to do to create hexamesh? Answer is easy. You divide, for example, here. Yes. So, and then you have this geometry full with hexamesh. Yes, did you understand? For example, okay, now it's good meshing. For example, in your examination will be the question, okay, how we can create hexamesh. It's how we can create hexamesh. So, for example, if I see this well, first what I'm doing, it's not this tetramesh. You see tetramesh is really bad, yes? If you make something finer, then everything is finer, then it's really not optimal. Yes, it's much more better to create hexamesh from the beginning. How I can create hexamesh? Very easy, yes? I see I have 3 places maybe, yes? Or I have, for example, this place. If I slide this place, so, yes. If I slide this place first, then I can slide, yes, then it's enough, yes, it has to be enough. Then I can slide this place, and of course, this place. So, and then I can create hexamesh. So look, if I go back, I show you an example how it works. It's a much question, for example, and then if I slide yet, I create new body, for example, around axis, no merge, so I can slice it like this one. Yes, then I can slide it like this one. So and so quickly I can create hexamesh. Okay, and then I can slide this body, this one. Okay, this body I can slide this one. So, okay, and then I can use my combine function, this body minus this. Yes, then I don't need this one. So then combine this body minus. Okay, you can do of course step by step, not everything. Then you will see where you can delete more. So divide this part. So and now I divide my geometry. Look, this is complete sweep. Yes. So I have if I slice like this one more. Okay, I have to slice of course. I have to slide it also here. Then it didn't work. Split body. So if I do it like this one now, then look, here is complete switchable. Yes, in this direction I have same geometry in same direction. So for example, this part also I can make hexamesh. Yes, inlet, outlet, same direction. So in reality, I divided only all this this between parts. Yes, connection parts. So and then I can create hexamesh. So for example, if in your examination you draw only, for example, only this one, yes, house, or like I don't know, if you do something like only you divide this part, yes, and you create hexamesh. But do you understand? Yes, you need to think about what you have to do to have this situation, inlet, outlet, one direction. Yes? For example, this part is my problem. Yes, if I delete this part, then I have inlet, outlet. Here I have inlet, outlet. Yes, here I have complete inlet, outlet, and only this part is a problem. If I delete this part, then I have also inlet, outlet. Yes? You understand? It's like logical task. It will not so be difficult in examination, but like this one. So this is the ideal solution. So if you do it in your practical work, then you understand everything. Okay, but we do it next in 2 weeks. We repeat it again. Yes, and do you have questions? Somebody? Nobody. Okay, then wish you a Merry Christmas and Happy New Year. And okay, it was for today.
Thank you.
Thank you. Yeah, it's not so easy, yes, but it's interesting. It's interesting simulation. And this is by ANSYS. So powerful. Okay. So good.